active volcano went off on the Earth on the right side of the moon, but it like splooshed magma. Would we see that on Earth? Like would we see like?
If it was on the side facing the Earth,
Yeah.
there's an awful lot of cameras trained on the moon. I would think we could see it. I know that right now, one of the things that's going to happen is they're going to try some laser communication to and from the moon with the satellite that just went up, because it'll be faster than infrared. You can send bigger bits of information. So then we could actually have a rolling video. You know how on the internet you can look at like what's happening in Yellowstone National Park? We'll have cameras set up like that on the moon. So if not now, certainly in the near future we could do that. Do you guys know the word lunar? You know, it refers to the moon, right? This is the moon. You notice it has a little face that we always see, and then the rest of it. When we talk about the 1 lunar day equaling 1 lunar year, for us, a year is how long it takes the Earth to go around the thing that it orbits, which is the sun. And that takes 365.25 days, right? That's a year for us. And a day for us is how long it takes to spin on our axis, 24 hours. Right? The moon orbits the Earth. So the amount of time it takes for it to go around the Earth is its year. That's the definition of it. How long it takes an object to make it around the thing that it's orbiting. So there's a year, and that's 24 hours. Now, that's 29 days. So watch. This side, the little smiley face, is always facing the Earth. And over the course of 1 week, it keeps facing the Earth. And 2 weeks, keeps facing the Earth. 3 weeks, and 4 weeks, it's made it all the way around, 29 days, right? It's made it all the way around. And in that time, this has done one full revolution. It starts like this, then it goes around and around and around and around. It revolves once on its axis. Do you see that? Can you see it from the little face? Should I run around you to make it clearer?
Yes. Yeah.
I will if you want me to. So if you're the Earth, and this is the moon, this face of the moon is always facing the Earth. So it goes like this. 1 week. Yeah. 2 weeks. And in 2 weeks, this thing is spun halfway around. Because it was facing this way, now it's facing that way. One halfway. 3 weeks.
No.
4 weeks. The dark side of the moon is this side that never faces Earth. Is it always dark? Oh, absolutely not. It's not always dark. We just can't see it. What's back here? Nazis. That's what the movie told me. It's got to be true. Okay, that's how that works. 1 lunar day equals 1 lunar year. It spins on its axis once in the same amount of time as it takes to go around the Earth once. I hope that works. We will play more with you. Tides. The gravity of the moon influences bodies of water on Earth. Only big bodies can you measure it in. Great lakes, seas, oceans. Not your toilet. It doesn't affect your toilet. And it causes high tides and low tides. The sun does some of that too, but it's only about half the effect of the moon. Is it going to rain tomorrow too? We have a little weather station out here. There were 1.13 inches of rain here, like the smallest in the area. I think my house had more than that. I know they had more than that south. 4 or 5 inches.
Last night, Lafayette flooded.
It's crazy. Okay. We will talk more about that. You already know it has an effect, but we'll play with it a little more. I just want to get the information out here. Ah, yes, this one. I've mentioned this to you. The moon orbits the Earth the same direction the Earth spins, although it doesn't look like that. That is to say, west to east. The Earth spins like this. Whoop. Hold on, I'm getting crazy. The Earth spins like this, counterclockwise as viewed from above. And the moon goes the same way. It doesn't look like that. It looks like the moon is going this way. But it's not, it's just going slowly. So it's right here, then the Earth, then the Earth spins around. Then it's here, then the Earth spins around. From on Earth I say, oh look, it rises in the east and sets in the west. But in fact, that's not the case at all. It just keeps going this way. And like I showed you the other day, it's just like you guys look like, like you're moving. That's what it's like looking from Earth at the moon. Looks like it's going one direction, it really isn't. It's an illusion. Oh, don't write this all down. All I want you to write down is that the moon has phases. The moon has phases. All these words, not important at the moment. You probably should say, though, the moon has phases that are caused by the viewing angle from Earth. Yeah, do write that down, because that's the thing that trips everybody up. Thanks, you guys are being very patient. We're almost done. I want to show you this. It says dock. We're going to go through all these phases, and some of them you may remember as you get older, and some you won't. This is the one that will help you not look like a doofus when you graduate from Harvard. Okay? Dock. And it goes like this. Can you see this, or is it all clear?
Yeah.
See it?
There's a new moon. New moon means you can't see the moon. There's no, all night long there's no moon in the sky. Then it starts with a tiny little crescent, a little tiny sliver of a moon that's arced on the right side, like this, like the capital letter D is. And over time it gets thicker, the next night, the next night, the next night, the next night, until you get to the first quarter. And then it keeps getting thicker, thicker, thicker. But we still have this pronounced curve here. This is called the gibbous phase, when it's between the quarter and the full moon. That is not nearly as important as understanding the curve starts on this right-hand side. Then finally it becomes full. Then, as the moon becomes not full anymore, what happens is this little side flattens out. And then it flattens a little more, then it flattens a little more, more, until you're down to this little crescent again like a C. That DOC is how you could look up at the sky any night and say, is the moon going to be bigger or smaller the following night? If the curve is like this, you say, oh, it'll be bigger tomorrow night. If the curve is like this, you say, oh, it's going to be smaller the next night. It's going away. This is called waxing, like wax on. And this is called waning, like wane off. It doesn't really fit the movie. But wax on, wane off. All right? The DOC is the deal. And that's the easiest way to remember it, the word dock. And if you don't remember anything else about the moon, I hope you remember this. All right? Next. Let me see. I'll show you how much more there is. That much right there. Okay. Eclipses. Oh, sorry. Wow. Some kids think that these phases of the moon are caused by the Earth's shadow hitting the moon. No. Not true. When the Earth's shadow hits the moon, that's a lunar eclipse. Sun out there, Earth shadow falls on the moon, that's a lunar eclipse. Then if I go this way, the sun is out there, here's the moon. Moon shadow falls on here. Now I can't see the sun, and it's a solar eclipse. Hey, there's the sun, there's sunlight right here. solar eclipse,
So
and a crime wave. Okay, so eclipses are about shadows falling either on the earth or on the moon. Am I going too fast here? Let me give you a second to jump back.
That's the new podcast.
First study hall.
What's the podcast?
Study halls aren't fun, are they?
first called
My son and I got walking out of the classroom today for weeks.
We should be that.
I think he walked outside.
Just come back next week, but
I'm 39 getting myself.
he just walks out, comes back in.
Okay.
Very little with that.
This part right here, we can probably sum it up in not right nearly as many words. Every night, the moon moves 50 minutes that way. It moves that much. So if it was directly overhead at 9 o'clock today, tomorrow it won't be directly overhead until 9:50, because it's going to rise over there. And then further that way. And then further that way. That's what that means. So if tonight at 9 o'clock, the moon is right here. Tomorrow at 9 o'clock, the moon will be here. And it'll be 9:50 when it finally gets dark. And then night after that, whew, it'll be over here, and that'll be 10:40 before it's. Okay? It's super predictable, measurable, all that. That's why we can predict the high tide so well, because the moon is so predictable. All right? And finally, the last four things. I think you know this. I think you know that the Earth orbits the Sun in 365.25 days. Remember the 0.25? That's all about leap year. That's why every 4 years we have to have an extra day on the calendar. Hello. Say it again. Absolutely. Let me just make this lower. Most of you know the Earth is tilted on its axis. 23.5 degrees is the number. Equinox thing we've already talked about in here. We know that the Earth is closest to the Sun in December, which for us is our winter solstice. And you may or may not know that time zones and time in general, they're invented, they don't exist. It's not real. Time is not real. Yeah, it just allows your parents to have a reason for you to go to bed at a certain time, and bosses a chance to yell at you for being late.
So my parents say go to bed at
Time is not
What
real.
is this time?
Well, you could even say, is this so I can do well in school? And they'll say yes. And then you can say, well, my school teacher told me that there is no such thing as time. Holy paradox. I'm sorry, parents. Okay? I know I threw a bunch up there, but that's all sort of afterthoughts. That was good. That was